This video is one of a series of videos I've made for students who are learning physics to prepare to enter a diagnostic medical sonography program. To find other related videos, please see my playlist, Physics for Diagnostic Medical Sonography Students. In this video, we're going to cover scientific notation. So why do we need scientific notation? Well, scientific notation is very helpful when we have either very large or very small numbers. And so let's just look at an example. Let's say we want to know, the distance to the sun in terms of a big number, or the diameter of an atom in terms of a small number. You'll notice that if we write these distances out in meters, we've either got a whole lot of zeros here or a whole lot of zeros here. And obviously, it's just not practical to work with all of those zeros. And so we need some type of a shorthand notation for writing very big and very small numbers. It turns out there are actually two solutions to this problem. One is to use scientific notation, and that's what this video is all about. The other way to do it is to use metric prefixes, and we'll be covering those in our next video. Scientific notation is based on the concept of exponents. So we're just going to take a minute or two here to review some of the basic rules of exponents, and then we'll see that those will help us understand scientific notation. The concept of an exponent is just, again, a type of shorthand. It gives us a way to represent a number that's multiplied repeatedly by itself. So for example, if we multiply 3 times 3 times 3 times 3 times 3, we don't want to have to write this whole thing out each time. And instead what we can do is just write a 3 with the number of times we're multiplying it together. So that 5 is called the exponent, or the power. And the number 3 here would be referred to as the base. So you'll notice it's really just a shorthand. It's a way to write something that otherwise would take a lot of writing into a very short compact form. Let's look at how to deal with exponents on your calculator. So in general, you may have a number of different calculators available to you. The one on the left is just the Windows calculator that's built into Windows, but your cell phone or whatever computer you have will have some kind of calculator built in. Each calculator can be a little bit different, but let's look at how to calculate 3 to the 5th on these two examples. So on the Windows calculator, I would just type in the 3, and then what I'm looking for is the x to the y key. And so if I do 3x to the y 5 equals, that's going to give me 3 to the 5th. And you might go ahead and try it on your own on whatever device you're watching this video. Go ahead and try it and just make sure that you get 243 as the answer. Now, a calculator that probably most of you have is some type of a scientific calculator like a TI-83 or a TI-84. On those TI series of calculators, the key that you're looking for is this one. So to calculate 3 to the 5th, I would do 3, and then that symbol, and then 5, and equals. And again, you should get 243. Let's look at some of the rules for multiplying with exponents. The rule is pretty similar. First of all, we need the numbers to have the same base. So in other words, in this case, the base is 3. Both the numbers have to be include a base that's the same. So in this case, again, a 3. So if we think about what that means, that's saying take 3 to the 5th, which is 3 times 3 times 3 times 3 times 3, and multiply it by 3 squared, which is 3 times 3. And you'll notice that what we get there is 7 3's, and so that would simply be 3 to the 7th. And so once you've kind of shown that to yourself, then you'll notice that really all we have to do is add the exponents. So in other words, if I have 3 to the 5th times 3 to the 2nd, all I need to do is take the 5 and add the 2. So I just add the exponents, and therefore I get 3 to the 7th. So that's how we multiply numbers when they have exponents. To divide powers of the same base, we do a very similar thing, except here we subtract. And again, just to understand why that makes sense, let's look at the following example. So I have 5 to the 6th. So we know that means 5 times 5 times 5 times 5 times 5 times 5. And then I'm dividing by 5 to the 2, which we can see is simply 5 times 5. Well, you'll notice that we can cancel out a couple of the 5's, and what we're left with is 5 to the 4th. Well, notice we could have gotten the same thing by realizing that what we want to do is subtract the exponents in this case. So in other words, if we have 5 to the 6th divided by 5 to the 2, what we want to do is simply write that as 5 to the 6th minus 2. We subtract the exponents, and that gives us the answer of 5 to the 4th. So those are our rules for multiplying and dividing with exponents. Now let's see, how does this relate to the concept of scientific notation? Well, in scientific notation, we use a base 10 to be able to write very big and very small numbers much more easily and succinctly. First thing, by the way, we should just review is the concept that anything to the 0 power is equal to 1. So that's an important thing to remember. Anything to the 0 power is 1. So in other words, 10 to the 0 would just be equal to 1. But if we look at these other values that I've written down, 10 to the 1, of course, would just be 10. 10 to the 2 would be 100. 10 to the 3 would be 1,000. 10 to the 4th would be 10,000. And we can then very quickly see that this is going to help us to be able to write very large or very small numbers in terms of powers of 10. So let's look at an example. Think about the following example, 8,300,000. Well, we can see that all that is 8.3 times 1 million. But we know how we can write a million. If we go back to that previous table and we just sort of keep working that up, we'll see that a million is the same as 10 to the 6th. And so you'll notice we've now got a way to write that number in a shorthand way. 8.3 times 10 to the 6th is the same as 8,300,000. Now there's a quick way to get to the answer. And again, once you kind of understand why it works, then you can really just use this rule. So it says for numbers greater than 1, count places to the left until there is one number to the left of the decimal point. The number of places moved is the power of 10. So in other words, if I want to figure out how to write this in scientific notation, I start with where the decimal point is, and I simply count how many places I have to move that decimal. So 1, 2, 3, 4, 5, 6. And so I would have 8.3. So I've moved the decimal place to here now. And how many places did I move it over? I moved it over 6. And so that's how to quickly get the exponent when you want to take a number and convert it into scientific notation. Let's do some practice. In fact, at this point, you might want to just pause the video and do these on your own just to make sure that you've got the concept. All right, well, let's go through them together. So again, all I need to do is count how many places I have to move the decimal. So here's my starting point. 1, 2, 3, 4, 5. And so I'd have 7.5 times 10 to the 5th. Now you might say, why do I move it that many places? What would happen if I moved it 4 places? In other words, what if we had taken that 750,000 and I had moved it 1, 2, 3, 4? Well, then I would have 75 times 10 to the 4th. That's also correct. You'll notice those are equivalent numbers, 7.5 times 10 to the 5th and 75 times 10 to the 4th. But when we have just one digit to the left of the decimal point, we call that standard notation. So standard notation means we only have one digit to the left of the decimal point. And that's our default. We always want to write our numbers in scientific notation in the standard notation. So for the rest of these, we'll just do them all in standard notation. So I'm going to go here, count 1, 2, 3, 4. So I'd have 4.9 times 10 to the 4th. Here, 1, 2, 3, 4. So 2.3 times 10 to the 4th. And then here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 3.45 times 10 to the 11th. Okay? And that's all there is to it in terms of taking a number and putting it into scientific notation. By the way, if you wanted to take a number out of scientific notation, you just do the opposite. So for example, let's use this one. I have 2.3 times 10 to the 4th. If I want to take that out of scientific notation, I'd start with 2.3. And now this 4th, I'd have to do the opposite thing. So I'd move the decimal to the right 1, 2, 3, 4 places and put zeros in there. And then just erase that decimal point. You'll notice we're back to 23,000. So that's how we deal with numbers that are very big numbers. We now want to look at how do we deal with very small numbers. Well, in this case, we need to use negative exponents. So first, let's just remember what a negative exponent is. Just in general, if I have a to the minus b, that's the same as 1 over a to the b. So that minus sign just means take 1 over that result. So for example, 10 to the negative 1 would be 1 over 10 to the 1. 10 to the 1 is just 10. So 1 over 10, or 0.1. You'll notice that 10 to the negative 2 would be 1 over 10 to the 2. That's 1 over 100, or 0.01. 10 to the negative 3 would be 1 over 10 to the 3. That's 1 over 1,000, which would be 0.001. And once again, you can see how we're going to have something that allows us to use a shorthand notation for writing very small numbers. Okay, so let's use this concept now and see how we can write small numbers in scientific notation. All right, so first I'll go through the concept and then we'll look at the rule that's on the slide. You'll notice that I could write this number as 9.76 divided by 10 million. So if you just try that on your calculator, you'll notice that I get the same value. But what is 10 million? Well, that's 10 to the 7th. So that's the same as 9.76 times 10 to the 7th. But we know that if I've got that exponent in the denominator, I can also write that instead in the numerator, but with a negative value. So 9.76 times 10 to the negative 7th. And that would be the number in scientific notation. Now again, once you kind of understand that concept, there's a much quicker way to get to the answer, which is to use this rule. So it says for numbers smaller than 1, count places to the right until there's one number to the left of the decimal point. So again, that's our standard notation. The number of places moved is the power of 10, but now it's a negative power of 10. So notice here, I just count how many places I moved the decimal. 1, 2, 3, 4, 5, 6, 7. But since I moved it to the right, that would be 9.76 times 10 to the negative 7. And so you'll notice that we can quickly get to the correct form of scientific notation if we use this rule. So let's do some examples. And again, you might want to just pause the video and do these on your own first, and then we can try them. Okay, so I'm moving the decimal place. I'm moving it to the right, so it's going to be a negative exponent. That's 1, 2, 3. So 7.6 times 10 to the negative 3 would be the correct answer. The next one, I'm moving the decimal 1, 2, 3, 4, 5, 6. So 1.32 times 10 to the negative 6th would be the correct answer. And the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that would be 3.48 times 10 to the negative 13. Now again, if I want to take a number and turn it back or take it out of scientific notation, that's easy to do. I just do the opposite. So let's take the 7.6 times 10 to the negative 3. Since we moved the decimal to the right to put it into scientific notation, I would do the opposite here. So that would be, I'll just write my 7.6, but now I'm going to move the decimal 1, 2, 3 places to the left, and that's where the decimal would be originally. Put in a 0, erase that decimal, and so you'll notice I get 0.0076, which is what we started with up here. So now that we know how to take a number and put it into scientific notation, we want to look at how do we manipulate numbers when they're in scientific notation. So for example, if we want to take two numbers and multiply them together and they're both in scientific notation, how do we do that? And the answer is that we just multiply the numbers that are in front, so 8.3 and 4.1, and then we add the exponents of the powers of 10. Because remember, when we have exponents with the same base, when we're multiplying, we can just add those exponents. And so what this would come out to be would be 8.3 times 4.1. So I'm just going to multiply those numbers that are in front. And then I'm going to add the exponents on the powers of 10. So I'd have 3 plus 7. And so if we do this math, we get 4.1 times 8.3 is 34.03. And then 3 plus 7 is 10, so I'd have that times 10 to the 10th. Now, you'll notice that the last step is, again, I want to put it in standard form, which means one digit to the left of the decimal. And so I want my final answer to be 3.403. And the question is, what do I put here? Well, we already have a 10 here. When I move the decimal to the left, remember that means it's a positive exponent. So what I've moved it 1 point, so this would be 3.403 times 10 to the 11th. Now, by the way, whenever you have to take a value like this and change it to standard form, just take a moment and think about what you're doing. These two numbers should be identical. They should mean the same thing. So it makes sense that if I've made the front number smaller, I've gone from 34 to 3.4, the exponent has to get bigger so that it means the same thing. So that's just a quick mental check to do when you're doing, moving that decimal either direction. When we're dividing numbers in scientific notation, it's very similar to multiplication. We start out by dividing the numbers that are before the powers of 10. So in other words, 4.3 times 10 to the 3rd divided by 8 times 10 to the 7th. I would take 4.3 divide by 8. So that's what would go in front. And then we subtract the exponents. So it'd be times 10 to the third minus 7. And if we do the math here, 4.3 divided by 8, we get 0.5375 is the number you'll get. And then the exponent would be 10 to the negative 4. So 3 minus 7 is negative 4. Now, again, the last step we'd want to do is put that in standard form. So notice that now I'm going to move the decimal to the right. Remember that when we move it to the right, the exponent becomes more negative. So since we had to move it to the right one place, we'd have 3.75 times 10 to the negative 5th. Now, most of the time when you're working with scientific notation, you're probably doing the calculations on a calculator. And so we want to look at how do we enter numbers into scientific notation on your calculator. And the way to do it depends again a little bit on the calculator. So on the Windows calculator, for example, we have this button called the exp button. And so let's say I wanted to take 3.5 times 10 to the fourth and enter that on my calculator. Well, in the Windows calculator, you'd type in 3.5, then you'd hit the exp key. So I do 3.5 exp, and then whatever the power of 10 is, which in this case is 4. Okay, so 3.5 exp 4, and when you see the calculator display it, it's going to display it this way. Notice that means 3.5 times 10 to the fourth. Some calculators will actually display it with that 10 in there, but for example, the Windows calculator doesn't. It uses an E here, which is a little bit confusing. So just know that when you see this notation, for example, let's say your calculator gives you that answer, what you'd want to write down on the paper is that, because that's how we humans write it. Now, how do we do it on a TI-83 or a TI-84? The key button here is right here. It's the EE button. And you'll notice that it's a second function. So if I want to put 3.5 times 10 to the fourth into my TI calculator, I do 3.5. I'd have to hit the second button. Then I'd hit the EE button. And then I would put in the exponent. Okay. And by the way, on the TI calculator, I don't have it in my picture, but down here at the bottom, there's a plus minus key. That's how you would change the sign of the exponent if you needed to. So when you type that into the TI calculator, the way it's going to display it is 3.5, and it uses a capital E to the 4. So again, if you see your calculator displaying a number like that, when you write down your answer, you'd put it back into human readable form, 3.5 times 10 to the fourth. The last thing I want to just briefly look at is adding or subtracting numbers in scientific notation. One common mistake people make is when they're adding numbers in scientific notation, they would think, oh, I can just add the 3 to the 7.6 and I would get 10.6. But that's not right, because we have to think about, what does this 3 mean? You'll notice that's 300, because it's 3 times 10 to the 2. Whereas this 7, since it's 10 to the 3, that's 7,600. And so we can see that the correct answer would actually be 300 plus 7,600. So how do we go about dealing with this when we have numbers in scientific notation? What we want to do is we want to convert the number with the smaller exponent to one with the one with the larger exponent. So in other words, what I want to do is I want to first rewrite this number with the same exponent. So then I would have 7.6 times 10 to the third. But now here, I'm going to write this as, since I want to change this to 3, I've made the exponent bigger, so I have to move the decimal place 1 to the left, or 0.3 times 10 to the third. So now once I have that, now as long as the powers are the same, now I can just add the numbers in front. And so you'll notice I get 7.9 times 10 to the third, or 7,900. And as we said, when we looked at the numbers outside of scientific notation, we can see that that's what it should be. And so that's how we add or subtract numbers in scientific notation. Before you do the adding or subtracting, just change the numbers, change the exponents to the same value. Now, all of these problems can be done with your calculator since you know how to enter numbers on your calculator. What I'd suggest you do is go through and do some practice with adding and subtracting numbers. So for example, try to do this problem by entering those numbers in your calculator and make sure that it gives you the correct final answer. Probably your calculator is just going to display it as that. So make sure that you get some practice with that on your calculator. Okay, in our next video, we'll look at the other way of writing large and small numbers with a shorthand notation, and that's metric prefixes.